David Smith here with one more Flip Classroom math video. 3 tips before we start. First, you can increase or decrease the playback speed if that helps you get through the video. Second, you can pause the video at any time to catch up with your notes. Third, you can turn on the captions to watch my words go by on the bottom of your screen. All right, let's review our recent chapter on functions. First off, we started by looking at functions and relations. Now, a relation is any relationship that you can graph, any set of ordered pairs, any scatter plot. You could just throw a whole bunch of dots that relate an x value to a y value. That's a relation. It's much more general. A function has a specific rule, and that is for every x, there's only one y. So you can't get multiple values of y for the same value of x. Tricky multiple choice question. Every function is also a relation. True or false? That's true. Every relation is always a function. That one's false. Let's take a look at a couple graphs here. 3 graphs here. Which one of these is a function or a relation? Now we have a special test that you can use to determine that. Go ahead and pause the video, look at these 3 graphs, come up with your answers. Okay. So this one is definitely a function. If we use the vertical line test, we can draw vertical lines through all of these, and it will only intersect the graph one time. That passes the vertical line test. This is a function. This one, check it out. If I draw a vertical line right through there, I am crossing the function 3 different times. That means for this value, x1, I could have 3 different y's. I could have a y there, there, or there. This one's a relation, but not a function. Check this one out. The vertical line test shows that I can only cross the graph one time with any vertical line, so that one is a function. Now let's take a look at domain and range for these 3 graphs. Remember, domain is the x values, the independent variable, and the range are the y values or the dependent variable. And with a function, y depends on x. Whatever x is, that determines what y is going to be. So how about the domain of this one? Domain is the x values. Do we have any limitations on our domain? The answer is no. We can put any number in for x and it's going to work, and it goes as far as it needs to that way and goes as far as it needs to that way. So the domain of this function is all real numbers. There's no limitations. How about the range? Now we have a limitation. Y cannot be less than -1. So the range of this function is a set of all y such that y is greater than or equal to -1, and it's a member of all real numbers. Now take a look at that one. Do we have any limitations on the domain? No, we don't. This function can go as far as it wants -x and as far as it wants +x. So that one is all real numbers. How about the range? What is the y value? What limitations do we have on y? This one is also all real numbers. We can have as far as it wants to go -y, that's the downward direction, and as far as it wants to go positive on y. So that one has a range of also all real numbers. Finally, take a look at that last one. It's the same as this one. No limitations on x and no limitations on y. All right, we also covered function notation. And that's shown here where we have f of x equals x squared minus 2x plus 1. F of x is just fancy speak for y, but it stresses the function nature of this function. So what it means is that y, or f of x, is a function of x. So whatever x is in here, that's going to determine what f of x is, or what y is. So one of the things we did there is we just did some plugins. What's f of 2? Pause the video and do that. So f of 2 means just take the 2, plug it in wherever you see x, do the math. So I have 2 squared minus 2 times 2 plus 1. That leaves us with 1. So what we get here is 4 equals x squared minus 2x plus 1. Now the way we solve these are we solve the quadratic equation. So that is we isolate all the numbers on one side, set it equal to 0, and solve. So I'm going to subtract 4 from both sides. That leaves me with 0 over here. X squared minus 2x. If I subtract 4, I get minus 3. Now we're going to solve this by factoring. This becomes x minus 3 times x plus 1. That's our reverse FOIL. And now we know that if this term is 0, the whole thing is 0, or if that term is 0. So this is going to give us x equals 3, and this gives us x equals minus 1. So if f of x equals 4, x can either be 3 or negative 1. Okay, here we are. We're finding domain and range with functions, and we're going to use algebra to do that. The graph is a little easier, I think. When you use algebra, you need your algebra skills, and you need to understand two conditions that limit the domain. The first one is you cannot take the square root of a negative number, and the second one is you cannot divide by 0. So those are the two things that you're looking for to limit your domain. So check out this first one. F of x equals the square root of x. The domain is going to be all real numbers, x such that x is greater than or equal to 0. If x is less than 0, we can't do this. Now the range, pause the video for a minute and see if you can figure out what the range is going to be. Okay, we can never get a negative number taking a square root. So the range is going to be the same thing. We're going to get the set of all y such that y is also greater than or equal to 0. We'll never get a negative number out of a square root. So check that out. That's that one. Okay, second one, 1 over x. The domain of this one is going to be the set of all x such that x is not equal to 0. Okay, we can't divide by 0. We can have a negative number there. That's no problem. We just can't have 0 there. So the domain of this function is a set of all x such that x is not equal to 0. Now pause the video and think about the range. Let's see how you did. For this function, there's no limit on the range. If x gets really big, the whole thing gets really small, approaching 0. If x gets really small, the whole thing gets very big, approaching infinity. And the same goes for the negative direction. So the range of this function can be the set of all x such that x is an element of real numbers. Now there's one more condition on this one that I forgot to put. Think about that real hard and see if you can figure it out. Okay, if you realize that y can also never be 0, you're correct. No matter what we do, the whole value of this function here will never end up being 0. There's nothing we can do to make it to be 0. As x gets super, super large, the whole function is approaching 0, but 0 is a limit. It cannot ever be 0. Okay, let's move on to this next one. F of x equals root x minus 5. So what is the domain of that function? Remember, we can't have a negative number inside. Okay, for this function, it's the set of all x such that x is greater than or equal to 5. X can be 5, because then this would be 0 in here, and the square root of 0 is just 0. But if x is less than 5, then this number is going to be negative, and we can't do that. So the domain is going to be limited to x being greater than or equal to 5. Now pause the video and come up with the range. Okay, let's see how you did. This one is really similar to this one. We're never going to get a negative number out of this function. Just won't happen. So the range for this one is the set of all y such that y is greater than or equal to 0. Okay, let's do the last one. 1 over x plus 7. Pause the video and see if you can write down the domain of that function. Okay, what you need to realize is that you just can't have 0 on the bottom of this fraction. That's the only limitation. So the domain here is the set of all x such that x is not equal to negative 7, because that would make the bottom of the function 0. Now figure out the range. Okay, if you figured out that y can't be 0, that's correct. There's no way you're going to ever get 0 out of this function. As x gets ginormous, the function goes close to 0, but that's going to be a limit, just like with this one. So I wrote here the set of all y such that y is not equal to 0. A quick word. You don't have to put y as an element of real numbers as long as you can specify some limit or some range of numbers. If there's nothing you can specify, then you want to say is an element of real numbers. Our next exercise dealt with what we call composite functions. This is where we take two functions and we kind of make one function out of them. So for example, if f of x is x squared and g of x is x plus 2, I'm going to ask you two questions about that. What is f of g of x? And so the way you do that is you just put the inner one in first. So g of x is x plus 2. Now f of x just takes whatever that is and squares it. So you take the g of x function, x plus 2, and you do the f of x to it, which is just squared. Now, oftentimes you want to simplify that. This is a binomial. This is a perfect square. So you're going to get x squared plus 4x plus 4. That's the expanded version. That's the factored version. Now I want you to pause the video and reverse that. Do g of f of x. Let's see what you get. Okay, this one's even more simple. We just take our f of x, we do that first. There's our x squared. Now our g of x just takes the f of x, whatever is f of x, you substitute that in for x, and you add 2. So we just have x squared plus 2. Okay, the last thing we looked at were inverse functions. And these are functions that take the x value and return it to x once you run it through both functions. So one function does one thing, and the inverse function does the opposite to it. So I'm going to show you a case where f of x and g of x are inverse functions. And I think you can kind of see it. X squared and root x, they're just going to, one undoes what the other one does. So let's check it out. Let's make a composite function. The way you test is you do that. So g of x is root x, and f of x is x squared. Now, the square of root x equals x. So that's the test. If you do the composite of the two functions, you should wind up with x. Now we can do the same thing going g of f of x. It should give us the same result. So f of x is x squared, g of x is square root, so the square root of x squared is also x. So that shows that these two functions are indeed inverse functions of each other. Okay, so now that you've seen what inverse functions do, let's talk about how to find an inverse function when you know the function. So our function here is f inverse of x equals 2x minus 6. The request you might get on a test or in the homework would be find f inverse of x. And that's all this -1 power thing means. It means f inverse of x. So if you know f of x, then you can go ahead and find f inverse of x. So the thing to realize is that we take this and we rewrite it as y equals x 2x minus 6. And then we switch x and y and solve for y. So we're going to get x equals 2y minus 6. So all I did is switch the x and y's. And now since x is the independent variable, we want to get y alone so that we can plug numbers into x and find out what y is. So basically we just have to solve this equation for y. I'm going to add 6 to both sides. I get x plus 6 equals 2y. Now to divide by 2 to get y alone, I'm going to move my y over to the left side and get y equals 1/2 x plus 3. So all I did is I divided by 2. I divided my x by 2, which is the same as multiplying by 1/2. And I divided my 6 by 2, which gives me 3. So f inverse of x equals that. I can just get rid of my y and do f inverse of x. Now, you might be asked to show that this is the inverse of that. And if you do that, that's using the composite function. So what you would do is you would do f of f inverse of x. And that would, if that ends up equaling x, then you know you have a correct inverse function. So let's do that. I'm going to put my inverse in the middle. So I have 1/2 x, plus 3. And now my f of x says take whatever that x is, which now is my inverse function, and multiply by 2 and subtract 6. So I'm just going to put parentheses around it, multiply by 2, subtract 6. Now this should reduce all the way down to x. So let's try that. I'm going to distributive property here. 2 times 1/2 is x. 2 times 3 is 6. So I have plus 6 minus 6. So yes, this does reduce down to 6 or to x. So I did my work correctly. I found my f inverse of x, did it right, checked it by going f of f inverse of x equaling x. Indeed, it does. Okay, let's do one more. There were some complicated problems involving rational functions. A rational function is just a function that has a fraction in it. So this one is definitely a rational function. We have 2x plus 2 over x plus 4. We're being asked to find the inverse function of that. So if you recall from the last board we just switch x and y. So I'm going to get x equals 2y plus 2 over y plus 4. Now I need to solve this equation 4y. So whenever you have fractions in an equation and you want to get rid of them, you just cross multiply. So I'm going to do this cross. I'm going to do x times y plus 4. That gets me xy plus 4x. And this one is x over 1, so that's just 1 times 2y plus 2. So I get equals 2y plus 2. Now I just need to isolate y on one side. So I need to first get my two y terms together so I can factor and cancel. I'm going to subtract 2y from both sides, and I'm going to subtract 4x from both sides. So subtracting 2y, I get xy minus 2y, and then I'm going to subtract 4x from both sides, so I'm going to get minus 4x plus 2. So now I have an equation with no fractions. I can continue to solve. Since I have two y terms, I can't quite divide it out yet, so I need to factor this. So I'm going to have y times x minus 2 equals minus 4x plus 2. Now I can divide by my x minus 2. X minus 2, these are going to cancel, and so I'm going to get y equals minus 4x plus 2 over x minus 2. So that would be my inverse function. So to finish this out, I would write f inverse of x equals minus 4x plus 2 over x minus 2. There you have it. With inverse functions, there's a certain thing that happens on the graph that you can exploit that's kind of interesting. So here we have two functions. We have f of x is 2x, g of x is 1/2 x, and you can kind of see that those are going to be inverse functions. If I take something, multiply it by 2, but then multiply it by 1/2, I'm back to that something. So what it is, I graphed these. The function 2x goes right through the origin, and it has a slope of 2, that's 2x. And then the g of x also goes right through the origin, but it has a slope of 1/2, and I did that. Now the trick here is that these two functions reflect across the line y equals x. And I did a pretty messy line there, but that is the function y equals x. If x is 2, y is 2. If x is 10, y is 10, and so on. Now this line is going to reflect right across this y equals x line to create that line. And the way you would know that is you would just draw a perpendicular line here. These two segments would be equal. Obviously on my graph they're a little bit off. So this would be the point 2, 4, and this would be the point 4, 2. So they have that kind of symmetry as it reflects across the y equals x line. Now that you've watched the video, take a moment to jot down any remaining questions so you can bring them to our next class. Remember, you can also come back to this video again and watch it for deeper understanding. If you liked or enjoyed the video, please click like or subscribe down below.